Welcome to Maths and Science by IITian channel. In this lecture, in continuation of my lectures on potential energy, in the last lecture we have seen regarding simple pendulum where V theta is taken. Here I have taken potential energy Vx in terms of x, that is equal to Vx is equal to alpha by 5 x cube plus beta by 7 h to the power of 4. Then we have to find out the omega under equilibrium conditions. How to find out that we have seen in the last lecture. Please see that video where potential energy, kinetic energy, conservation principles are used. Here we will be using the energy conservation principles and solve this problem. Potential energy is given in terms of x. In the last class it was in terms of theta. In this lecture it is in terms of x, it is given. We have to find out the angular frequency. Now, what is the given question? Question is, what is given in the question? Potential is given in terms of x, that is equal to alpha by 5, some constant alpha by 5 into x cube plus beta by 7 into x to the power of 4. Then what is the value of dou Vx by dou x? That is equal to d by dx of Vx. Rather we can write this way also. That is equal to let us take the differentiation of this. Alpha by pi is a constant. D by dx of x cube is 3x square plus beta by 7 is a constant. X to the power of 4 is 4x cube. That implies dou Vx by dou x, it's a partial differentiation. That is equal to, this I have written it for the people to conveniently see it. Partial differentiation may not be equal to exact differentiation if 2 or 3 more terms are there. Here it is only x is there, then we have equated it and I have shown, because people are familiar with this d by dx. Here it is called as dou by dou x of Vx. That is nothing but derivative. Now, how we can write it? Alpha x square, can we take it as common? Not alpha x square. We can take it, what we can take as common? X square we will take it as common. X square into 3 alpha by 5 plus 4 beta by 7 into x. That is equal to x square into 21 alpha plus 20 beta x whole divided by 35. This should be equal to 0 for equilibrium conditions. That means dou V by dou x should be 0 for equilibrium conditions. Please remember this condition under equilibrium. Okay. Now, what happens? This equation becomes 21 alpha plus 20 beta x is equal to 0. That is one condition, or x is equal to 0. That implies x is equal to, if you take this out, minus 21 alpha by 20 beta. That is minus 21 by 20 alpha by beta is equilibrium position. Now, at x, at this particular x, we have to find out the omega. What is omega? Omega is equal to, what is the formula for omega? In the last lecture we have seen what is the value of omega. Angular frequency is square root of 1 by m into, because here we have not taken what you call theta. Please see the change. Here it is x, dou square Vx by dou x square at x is equal to 0. That I is gone instead of 1. 1 by I is used when theta is there, because theta is dimensionless. We treat radians. Here already we have taken dou x square. What are the dimensions of dou x square? Please tell me. Dou x square or dx square, units are L square, dimensions. Please remember this. Already L square is taken care of in dou x square. Hence, we have divided by m. This you please remember this change. In the previous simple pendulum it was I, because it was I is equal to ml square. Here L square is already taken care of by x square. Hence we need not write again I. 1 by m dou square Vx by dou x square. This is the formula. Please remember this way, so that you can remember very easily. I am not going to derive this. This is beyond our scope, beyond our syllabus at present in this. Now, this you know Vx, then dou square Vx by dou x square you can easily find out. What is dou Vx by dou x? Dou Vx by dou x is equal to, we have already calculated, x square into x square by 35 into x square by 35 into 21 alpha plus 20 beta x. Now, this can be dou Vx by dou x is equal to 1 by 35 into 21 alpha x square plus 20 beta x cube. Now, differentiating, what happens? Dou square Vx by dou x square 1 by 35 into, differentiate this, 21 alpha is the constant, x square differentiation is 2x, plus 20 beta is a constant, x cube differentiation is 3x square. And what is the value of x? We have to put x is equal to not 0, x is equal to minus 21 by 20 alpha by beta. Minus 21 by 20 into alpha by beta. You put this value. Then it becomes 1 by 35, 21 alpha into 2 into minus 21 by 20 into alpha by beta plus 20 beta into 3 into minus 21 by 20 whole square into alpha square by beta square. Now, you have got dou square Vx by dou x square. Then what is the formula for omega? Omega is equal to square root of 1 by m into dou square Vx by dou x square. Dou square Vx by dou x square is 1 by 35 into minus 21 into 2 into 21 into alpha square by 20 beta plus 20 beta into 3 into, instead plus we will make it as minus, this is plus only because minus 21 by 20 whole square. 21 square by 20 square minus square is, that is whole square, that is plus. Alpha square by beta square into alpha square by beta square. This is a simple simplification. Now, let us simplify this one. Omega is equal to square root of 1 by m into 1 by 35 into alpha square by beta, and here beta gets cancelled. Alpha square by beta. That means alpha square by beta, that we will take it out common, into 21 square into 3 divided by 20 minus 21 square into 2 divided by 20. 3 minus 2 is 1. 21 square by 20. Therefore, omega is equal to square root of 1 by m into 1 by 35 into alpha square by beta into 1 into 21 square by 20. 21 square, how we can write? Let us write like this. 21 into 21. Now, 7 5s are 7 3s are. That means it will be square root of 1 by m into 63 alpha square by 100 beta. That implies omega is equal to, we will take out 100 also out of the square root and alpha square also out of the square root. Then alpha by 10. Square root of 100 is 10 into square root of 63 by m into beta. This is the answer. This is derived from the principles of conservation of energy. Conservation of energy. We have never used any force formula or vectors. We have used the principle of conservation of energy and derived this. This is the fundamental concept of Lagrangian mechanics. We have not started the Lagrangian mechanics yet, but it is the fundamental concepts we understood now about the Lagrangian mechanics. There are two types of mechanics. One is Newtonian mechanics, another is Newtonian mechanics that uses force, vectors, etc. Lagrangian mechanics, it uses scalar energy principles. Whatever the system is convenient for you, that system you can apply in the examination and do it fast. And I will teach both Newtonian mechanics and also Lagrangian mechanics. And this is the fundamental application I have shown in this example. If you feel there is a value addition to your knowledge with this video, please subscribe to my channel. Subscribe to my channel Maths and Science by IITian, and please share my videos and channel details to known people. This will write it clearly, Lagrangian mechanics. It is Lagrangian mechanics. It uses the principle of scalar and energy principles, whereas Newtonian mechanics, both are very competent. It uses vectors, velocity, acceleration, force, these things it will use, whereas Lagrangian mechanics goes for scalar and energy principles. Both result in equation of motion. Same equations of motion. EOM is equations of motion. Ultimately, we are interested in the motion of the object, movement of the object. What happens if it moves in that way? In which manner the object is going to move? That's more important. That's what we are interested in. With this, I want to conclude this lecture. Thank you for listening to me. Best of luck to everybody. We have started a path in understanding the Lagrangian mechanics. We will try to do justice to it, and we will try to observe more and more concepts on Lagrangian also, so that you will have two methods for solving mechanics problems in the examination. You can apply either Lagrangian or Newtonian. That's up to you. Best of luck. Thank you. Please subscribe to my channel and share my videos and channel to everybody known to you. Thank you.